In this video, we're going to look at proving the laws of logs. So what we're going to do is we're going to start off with the following. We're going to say, let P be equal to log base A of X, and let Q be log base A of Y. So what we're going to do now is we're going to say, right, so if we got P equals log base A of X, we want to write this in exponent form. So remember how to do this. So we say A raised to the power So we'd say A raised to the power of P. So we say equals X. So now we do the same thing here. A raised to the power of Q equals Y. So now that we have it in exponent form, we can now say, well, what's X times Y? So we know that X times Y will be A to the power of P times A to the power of Q. Well, you know from GCSE, that's A to the power of P plus Q. So we can now say, so XY is A to the power P plus Q. So we're now going to write it in log form. So we're going to say log base A of XY is equal to P plus Q. So now we can say, well, I know what P is. We said that P was log base A of X. So we could say, therefore, log base A of XY, well, P is log base A of X. And we also know what Q is. If we go back to the top, Q is log base A of Y. So we could replace Q with log base A of Y. Now that is the first law of logarithms. Now to prove the second law. So everything's the same as before. We say P is log base A of X, Q is log base A of Y. So we go from log to exponent form, which is A to the power of P equals X, and A to the power of Q is Y, as previously shown. So this time we're going to say that what would be X over Y? Well, X is A to the power of P and Y is A to the power of Q. Now we know from the laws of indices, that's A to the power of P minus Q. So we can say X over Y is equal to A to the power P minus Q. So we can write this in log form. So it's log base A of X over Y is equal to P minus Q. Now, since we know what P and Q are, we could replace it by saying, therefore, log base A of X over Y. We said that P was log base A of X and Q was log base A of Y. And that proves the second law of logarithms. Regarding the third law again, so we're going to say let P equal log A of X, and we're going to write this in an exponential form. So we say A raised to the power of P, that's A raised to the power of P equals X. So now, what we're trying to show is what would be x raised to the power of n? Well, x in our case is a to the power of p. We know from the laws of indices that's a to the power of pn. So now we can do the following, that x to the power of n is a to the power of pn. So now we do logs, so log base of a of x to the power of n equals to pn. But we know what p is. That's log base a of x. So we can say that's equal to n times log base a of x. And that proves the third law of logs.